This problem would be much nicer to do if we used elimination instead. But since we're supposed to use substitution, what can we do? So we can have from 1 1/3 y equals 2x plus 15. Or we could just substitute using the 2x instead. But then we would end up with a mixed fraction at the end. And personally, I don't like mixed fractions very much, so I'll do both methods. Or the other method would be from 2. We would get 2x equals 37 minus 4y. Of course, we could also do this from 1 because this is also 2x, and that would be, well, you get the idea. So 1/3 y minus 15. Now, here from 1, if we did it this way, we would go on to do so how many 1/3 are in 4? We would get 12 times 2x plus 15 and plus 2x equals 37. 12 times 2x is 24x plus 2x, 26x. Plus, well, 12 times 15 is 180. This is equal to 37. Now, the following, some of us may prefer to use a calculator for this, and of course, if you wish to, there's no problem with that. Equals, this should be negative 143 because you subtracted 180. Now, what next? Well, of course we divide over, but before we divide, what can we first see? Okay, 143, that's 130 plus 13. This is 26. That's 2 times 13. So, what can we do? Well, first of all, we can cancel this out to, if we want to do this by hand, it is more practical to cancel first, in which case this becomes negative 11 and this becomes 2. But if we did this by calculator, we would find ourselves with negative 5.5. Now, for y, we know that 1/3 y equals 2x plus 15, or alternatively just sub into 1. And this gives us, let's make some room, 1/3 y minus 2x equals 15. So 1/3 y minus 2, negative 5.5. As you can see, when substituting, it's sometimes kind of hard to keep your equal signs all in one place. Hence why previously we would write equal signs first. This demonstrates some of the difficulty. So equals, well, 15 and sus. We can choose to write 1/3 y plus 11 equals 15. And this leads us to an irritatingly large number of steps. we could have just done this to begin with, which would have put us straight to 1/3 y equals 4, and y equals 12. Now, in addition to these solution, brace bracket, x equals something, y equals something, there is also another method of presenting the solution. X equals negative 5.5, y equals 12. Because as we well know, when you present an ordered pair, it's usually x comma y when we describe, say, a point on the graph, or x comma y comma z, or even a, b, c, d, e, f, or something similar. So there is no problem in writing it out horizontally as well as the brace bracket version. So we could go back and do it the other way, but to save time, nah. And because it's kind of tedious. Hopefully we've covered enough examples that we all know how to do substitution now. Usually you reduce it down to y equals something or x equals something and then substitute. But we can also make it so that it's some multiple of y or some multiple of x that also exists in the formula that we're substituting into. Actually, we can even do, say, 1/3 y and substitute that into 4y if we pay attention. So we see that substitution does not actually require what they usually ask you to do, which is to make it y equals something. Of course, there is merit in doing it that way if you're just getting started out and you don't want to be spending too much time thinking on, how many times does 5/7 fit into 25? Of course, you don't want to spend too much time on that stuff. So you would do it down to 1y or 1x equals something. Now, when we do problems, there are just problems where they give you the problem and you do it. Done. But there are also word problems where you have to understand the problem and figure out how to do it, how to model it using math. And then you do the problem. So here we have an airplane that travels with the wind. It flies 1,500 kilometers in 2 hours. On the return trip, it takes 3 hours to travel the same distance because it flies against the wind. If the wind is still, what is the speed of the airplane? So the airplane relative to the wind, usually we start this with let speed relative to wind be x, wind speed to ground be y. This should have a comma here to denote that no, while grammatically still terrible, this is not a complete disaster. Math does not put very many constraints on grammar, which means that, well, hopefully, your math teacher does not also mark, say, English homework. Now, what does this say here? Well, okay, 1,500 kilometers in 2 hours. That's clearly 750 kilometers per hour, right? So, we have the wind speed to ground and the airplane speed relative to wind, both being positive. So both going in the direction of the flight, and that gives us x plus y equals 750. Now, if it was x minus y, we would have 500. Technically speaking, using elimination is a much better way to solve this problem, but since we're supposed to use substitution for this section, well, that means while you don't have to put brackets in front if it's just printed onto a problem sheet or something, when you write out formulas yourself, it's generally a good idea to put a brace bracket on the front just so that you don't mix it up with, say, your next step. From 2, we have x equals 500 plus y. So, $500 plus y equals 750. Now, 500 plus 2y equals 750. And yes, I do realize I'm writing it out a little bit long here. But when doing examples, one should act at least vaguely exemplary. And no, please do not throw any type of rotten produce at the projector for the sheer lameness of the pun. Now, what about, well, if we could just substitute into this, it would be somewhat easier, right? But substituting into 2 does exactly the same thing because we can do the substitution and then the next step we can already have moved it. Sub into 2, and this would lead us to x minus 125 equals 500. So x equals 625. Now, technically speaking, since this is a word problem, we aren't just looking for numbers. We're actually looking for real information. In this case, the speed of the airplane if the wind is still. So the airplane speed relative to the wind is 625 kilometers per hour. This is called the air speed. So the speed relative to the air surrounding the airplane. The plane is 625 kilometers per hour. Of course, you should make sure that your teacher knows what airspeed actually means. Otherwise, you'll actually have to write the speed of the airplane relative to the wind is instead. Now, example 3. During a canoeing trip, it takes John 6 hours to paddle 20 kilometers upstream. As we well know, upstream is where the water comes from, and downstream is the direction it flows in. At least, I hope we know this. So, it takes him 4 hours to make the return trip paddling downstream. Find the speed of the canoe in still water. Now, let speed of canoe relative to water be x. And current, because that's just what we use to describe the flow of the water. Current speed be y. Find the speed of the canoe in still water. So, we have, the speed of the canoe relative to the water, minus the current speed is equal to the speed over this distance, which means x minus y equals 20 over 6, and x plus y is equal to 20 over 4. So 1, 2 from 1, x equals y plus 20 over 6, and sub into 2. Why do we always sub into the one that we didn't get it from? Because if we sub this into this, all we'd get is 0 equals 0. Well, hallelujah. Of course 0 equals 0. So we have to substitute this from 1 into number 2, or vice versa, if we want to actually find a solution. So this comes out to y plus 20 over 6, and I do realize this is equal to 10 over 3 plus y equals 20 over 4. Now, and I do realize this is 5. So, what do we do next? Equal sign. 2y equals 5 minus 10 over 3. So that's 2y equals, well, 5 minus 10 over 3 would be 5 over 3. Y equals 5 over 6. And then what do we do? Well, we look back at the problem. What did we set things to? Oh, we want to find the speed of the canoe in still water. So here we notice that the speed of the canoe relative to the water is x. So what we're actually interested in here is clearly x, not y. So what do we do? Well then, we can choose to use any of these, but really since this is so much more convenient, we will sub into 3. Yes, it is usually preferable to sub into what you start with, but since we can sub into 1 or 3, really, it doesn't particularly matter. So let's use, well, yeah, 3 then. Because regardless, as we can see, 3 comes straight from 1. So x equals y, which is 5 over 6. Some people like to put brackets around the numbers whenever they substitute in. Others only do so if they have to multiply, plus 20 over 6. So this is equal to 25 over 6. Now, what are the units? Because what are we looking for? We're not looking for just a number. We want the speed of the canoe in still water, and it's kilometers per hour. So, the speed of the canoe in still water is, we can just put this 25 over 6 km per hour, or we could put it in mixed fraction form. Now, last example for this section. A lab needs to make 200 liters of a 15% acid solution by mixing a 10% and a 25% solution. How many liters of each are needed? So, total acid is 200 times 0.15 equals how much? Well, clearly 30 liters. Now, here we make a very, very chemically speaking inappropriate assumption in that we assume when you mix the 25% and the 10% that the volumes just add together. Chemically speaking, that's a little bit off, to say the least. But for mathematical purposes, we can assume these are volume, which means that they wouldn't be off. Why? Because 15% of the volume of the final solution is acid. Okay, fine. Wait a second. If these are also volume, then 10% of that volume is acid. Okay. And 25% of this volume is acid. Fine. And in the end, we get volumes of acid added together. And that's this. Okay. That is the only way that this can work. Fortunately, if you've ever seen a bottle of vinegar, you sometimes see 5% volume. That means volume of acetic acid per however much solution. So, only when this is volume does this actually work when you are adding in chemistry. But for math purposes, we don't really care what it is. So, total acid is this much, total volume is that much. That means we have, let's use, it's not always let something be X. You can also use slightly less official terms, and typically teachers will let you get away with it. Of 10% and Y liters of 25%. What does this bring us? Well, X plus Y equals 200 and 0.1x plus 0.25y equals, please note that depending on regional preference, you may want to line both up to the brace bracket, or you might want their enter signs to line up, or there could be no preference whatsoever. This is also a personal thing, depending on if your region doesn't care. So, this is 30. Now, clearly this tells us that x equals 200 minus y. From 1, x equals 200 minus y, and because we have to do this by substitution, sub into 2. This brings us to 0.1 times 200 minus y plus 0.25y equals 30. So 20 plus 0.15y equals 30. And 0.15y equals 10, and y equals, well, we could choose to use a calculator, or we could think of this as 1,000 divided by 15. So, if we wanted to do the 1,000 over 15 route, because you aren't supposed to use decimals in fractions, for them usually. So here this would cancel out to 200 over 3 liters. And x equals 200 minus y, so Let's say we substitute into 1. To 1 x plus 200 over 3 equals, well, 200. Therefore, x equals, what do you think? 200 times 3 is 600 minus 200 is 400 over 3. Or alternatively, we could just recognize that this is 1/3 of 200, and therefore 2/3 must be double of this. Liters. So, in a word problem, we will typically answer with, we need 400 over 3 liters of 10% and 200 over 3 liters of 25% acid. And that's it for this section. Hopefully we've done enough substitution problems that you have a good grasp of how to use them, even if you don't use 1 or even an integer for your coefficient when you are initially substituting. So we'll see each other again next section then.